Hello everyone, myself Parth Ghadiya and welcome to my final portfolio presentation for Studio 3 Integrated Construction Practice. In this studio, I work on a high-rise commercial tower project located in the GIFT city. The projects allow me to explore BIM coordination, place detection and on-site process planning. In this video, I will talk through the project brief, class detection, workflow, resolution process and the last planner system implementation on the site. Moving towards the project brief. This commercial tower is a 29-story building with a 3 basement built as a greenfield development. The project has land area of 5,970 square meter and the total built-up area of around 66,600 square meter. The contract type is a item rate and the total construction cost is approximately 160 crores. The project duration is of 42 months from November 2023 to the July 2027. The objective of this project is to create a sustainable, smart and efficient commercial spaces within the strong connectivity to metro and public transport. Scope of work for this studio is a basement 1 and 16th floor, and for the last panel system 4D and 5D simulation we took the 23rd floor. Moving to the clash detection. One of the key parts of the studio was the clash detection. This process flow showing the clash detection into the Navisworks, integrating all the model in Revit, exporting to NWC format, importing into the Navisworks, running clash detection test, applying the rules and generating reports. We integrate architectural, structural, mechanical, electrical, plumbing and fire model into Revit and export them into Navisworks. Similar with we also did the clash detection in the Autodesk Construction Cloud. This is the process flow of the clash detection in the Autodesk Construction Cloud. This clash matrix shows the number of the clashes detected into each iteration, starting from the major conflict between the architect and structure to the MEPF systems. This helps us to understand how model refinement reduce the clash across all the iterations. As I mentioned earlier, we did a clash detection for the Navisworks and Autodesk Construction Cloud. So this is the comparison between both software. Navisworks offer the advanced and detailed clash detection and best suit for the deep MEP and the beam coordination. On the other hand, Autodesk Construction Cloud provide the cloud-based accessibility, automated clash detections, and the real-time collaboration. This comparison helped me to understand which platform is more efficient at the different project phase and the more different for the stakeholders. Moving to the clash detection resolution process flow. Integrated all the model in Revit, exporting to the NWC format, importing into the Navisworks, running clash tests, applying rules and generating the reports. After identification of the clashes, assign each and every relevant clashes to the each discipline. This systematic workflow helped me to identify errors in the early stages and improving the interdependency of the coordination. It also taught me to how the clash detection fits into the real world BIM execution planning. Moving towards the clash resolution. Here we can see example of the actual clash identified in the model. Majority clash are the modeling errors such as the column slab clashes, pole intersection, and very few were design clashes such as the duct and pipe intersection in the 16th floor and a duct and column intersect at the basement one. We analyze this clash and give proper spacing between column and duct and resolve these design errors. Similar way, each clash was analyzed and resolved by us and adjusting modeling elements or correcting design inaccuracies. This hand-on exercise strengthened my understanding of beam accuracy and coordination between structural architecture and MEP team. These are the additional clash resolution classes. In this we include cable tray conflict with walls and columns, conduit overlapping, firefighting system clashes, and electrical design errors. Each clash was categorized as either a modeling error or a design error. Resolving this improve overall quality of the model and we make the clash-free model and reduce the possibility of the on-site rework. Moving towards the last planner system implementation on a site. The second major task was implementing last planner system on a site. Last planner system aims to improve the schedule reliability by planning work in a weekly cycle, identifying the constraint and the measuring actual process. In starting, we have a master schedule or the milestone schedule. After that, preparing the phase schedule and the make ready schedule. Out of that, we preparing the weekly look ahead planning for the week. After that, tracking each and every activity during the whole week and find constraint and make weekly percentage plan complete. We prepared the look ahead plan for the 3 weeks based on our site process and constraint observed during the site visits. Moving toward the last planner system for the week 1. Here we can see that the detailed analysis of the week 1 look ahead planning and the tracking. We clearly see that here is the week 1, there is a 8 activity plan that completed in this week. In week 1, the labor sorted during the Diwali causes delay, resulting out of 8 activity, 3 activity completed as a planned day. Out of 8 activity, 2 activity completed within the week but not as a planned date. And out of the 8 activity, the 3 activity was not completed. So 5 activity completed on the week. So we achieved the percentage plan complete on the 62.5 percentage, and the main causes of that particular week is a labor shortage during the Diwali. Moving towards the last planner system for the week 2. In week 2, we clearly see that the 6 activity planned for the week in the look ahead table. While tracking of the week 2, we identify that the crane unavailability affected the progress. In that 4 activity completed on the same day as planned, 1 activity completed the later in that week, and 1 activity were not completed, to giving the percentage plan complete of the 83.3 percentage. This is the site documentation. These are the picture I clicked during the tracking of activity in week 1 and week 2. Moving to the look ahead planning for the week 3. Week 3 focus on a starting activity of the 24th floor cycle with the column reinforcement, shuttering work, shear roll works and the slab concreting. Total 7 activity planned to be completed in a week 3. Through this process, I learned how workflow reliability, resource planning and the sequencing impact in the actual process. To conclude, this studio helped me to understand how digital coordination and on-site workflow are interconnected. Clash detection improve the accuracy of the beam models and the strengthen coordination between all the discipline. The last planner system improve the planning discipline, highlight the variance and improve my understanding to production control and the percentage plan complete. Overall, this studio gave me hand-on the experience combining the beam tools, planning methods and the real site condition to improve construction predictability and efficiency.